The robotics program in Edinburgh has been active for the past 10 to 15 years, and we've been trying to take it to the next level. NASA basically have built this incredibly complex, very able humanoid platform that still requires a lot of work in terms of making it do the things that it's capable of doing.
My name is Sethu Vijayakumar. I'm a professor of robotics at the University of Edinburgh, and I'm also the director of the Edinburgh Centre for Robotics. We've had the relationship with the Johnson Space Centre for the past 2 years, conceptualizing and building this project, and we are really looking forward to the next generation of robotics and humanoid platforms that are going to come out of this collaboration.
Much of the work that NASA does, you've seen the rovers on Mars and the deep space probes, and even a lot of the work that's done on the human side, which is where Johnson Space Center is involved, it relies heavily on robots. We are into robotics from an enabling technology standpoint. The humanoid that you see in there, it doesn't necessarily make sense for a purely zero gravity type mission. NASA is not purely a zero gravity type agency. We're looking to go to Mars, and we're going to go to Mars. And when we get there, we're going to need robots to do the same types of things that they do for us in the space station. We're going to need a different kind of robot. Valkyrie's a step towards that machine.
The Valkyrie is very, very modular, and that really reflects the ethos of the space program, because robots that go to space have to literally change shape because they have to come in a very compact fashion into the space shuttle. Then at some point they have to either deploy themselves or metamorphose into something which is more like a proper bipedal robot.
We're attempting to leverage the humanoid robots that we built for space while adding the bipedal locomotion capability that would be required in a more unstructured environment.
There have been walking robots for 20 years, but throughout the development of both walking robots and mobile robots, there's been a continuous development of technology. So you can see with Valkyrie, it has force sensing in its joints, it has padding in its shoulders and limbs, it has the actuation possible to, for example, lift up 2 or 3 kilograms of an object, something that previous generations of robots weren't capable of doing. It's able to support a battery so as to operate for over an hour, and it's able to operate with all its computing on board. These are evolutionary capabilities that are being generated every new prototype.
Control, sensing, and actuations are still a big challenge. In simulation, because you've got perfect sensing and perfect control of the state of the world, you don't see those problems. But on real hardware, small drifts can create a big discrepancy.
We're training the students in these technologies, from formal algorithms for estimating and understanding the robot's behavior through to control algorithms and control theory.
If you come and visit us in 6 months' time, there will be lots of "I wish I've never started this," sleepless nights, and people missing their birthdays. I think it will all be worthwhile.
We've been here a week, seeing the robot behave in ways that we haven't done or been able to do at home.
So we look forward to it and maybe watch the space.